episode 17. We'll first start with this diagram. It's the diagram of the globe, and there are quite a few symbols here. We'll try to understand. This is a North Pole, this is South Pole, this, and there is a prime meridian, and we have a shaded loon, inside which is an A with the cap on top of it, is an area enclosed between two latitudes and two longitudes. So here's, and this is called the spherical loon. Here is what the real picture is. We have a prime meridian which starts from the North Pole, goes all the way to the south, and on the globe this is prime meridian, and in the middle is an equator. That's what it is here. And we have a theta cap which represent longitudes. The longitudes is the line starts from the North Pole all the way to the South Pole. Here is prime meridian and another longitude, and this is called the 15-degree longitude. This is a 30-degree longitude. It goes from the North Pole to the South Pole, and this is 45-degree longitude. Since there is too much information on the globe, that's why I drew some here. So this is, each of this longitude is represented by theta cap. So this is a 30-degree longitude west and 60-degree longitude west. Same is the case with the latitudes. These are called the parallel of latitudes. This black line is parallel to the equator, and the latitude lines on the globe are, this is 60-degree north latitude, this is 45-degree north latitude, this is 30-degree latitude, and this is a Tropic of Cancer parallel to all this, and this goes all the way to this. But we have a different symbol to represent latitudes. We use the theta cap to represent the longitude, but we use B to measure the latitude, which is a measurement along the axis of the globe, which is this B1 and this is B2. This is the distance between two latitudes, which starts from North Pole. And this is the loon. Loon is the surface area between two longitudes. And now we have, I think we can understand this diagram, that our equator is in the middle, Tropic of Cancer is parallel to it, and we have a loon in the shaded one, and we have a theta cap, which is the measure of longitude from meridian. This episode is a continuation of episode 16. We have a globe of diameter d, the surface area of which is pi d square. We drove an equation to find the surface area between parallel of latitude. So the equation we drove is this one, where AB is the area between two latitudes equal to pi d, and this is the integral starting from b1 to b2, and this is the b1 and b2. So the area of latitude is between these two parallel latitudes. If, on the other hand, we divide the surface area along longitudinal lines, we'll get spherical loon as we have shown, and this green shaded one is a spherical loon. By following the same line of reasoning we used in episode 16, we can derive an equation for the area of a loon, which I represented with a theta cap, and that is, the surface area is pi d square, so we won't touch the d square here, and we will deal only with the pi. So we can divide 2 pi by 2 times d square, and d square by 2 times integral from 0 to 2 pi d theta cap, where theta cap is an angular displacement of longitude along equator. We'll measure theta cap in radians. It starts from prime meridian and has positive value towards west. The area of loon becomes theta a theta cap equal to d square by 2, and the integral starts from theta 1 cap to theta 2 cap, and this is our second equation. Let's do an example to understand what this equation means. Calculate surface area of spherical loon shown when d is 2 foot. So this is the green spherical loon which we need to calculate the area of which. So it's just very simple. We have, since theta 1 is 30 degree and we will take it in radians, so theta 1 is 30 degree and theta 2 is 60 degree. So the upper limit is 60 degree. So theta 1 is 30 degree, which is pi by 6 radian, and theta 2 is 60 degree, which is pi by 3 radian. Therefore the solution a theta cap become pi by 3 foot square. Now if we combine equation 1 and equation 2, this was our equation 1, which we used to measure the strip area between two latitudes, and this is the equation we used to measure the area between two longitudes. So combining these two equations will get, since radius is equal to diameter by 2, we have this equation A cap equal to, from r times theta cap 1 lower limit of integral and theta 2 cap upper limit, and it is multiplied with another integral which is from b1 to b2, and this is that inset. This A cap is the area which we calculated right now. Let's do an example. This is another example. Find the inset surface area marked by red boundary as shown when diameter is equal to 2 foot. So we are trying to find the area enclosed within this red boundary. And this is very simple. Is r is 1 and theta pi by 3 theta is integral is pi by 3 minus pi by 6 times sine 23.5, and this is the distance between two latitude, and it is the difference between B2 and B1. Since we are using a globe, and globe has this value of Tropic of Cancer, so it is here Tropic of Cancer, this dotted one, and it has a value 23.5 degree north. So we'll get an answer approximately equal to 0.2088 foot square. It is pretty straightforward so far. Theta cap is proportional to multiplication of the difference of theta cap and b. That means it's only that is A cap is proportional to theta 2 cap minus theta 1 cap times B2 minus B1, where constant of proportionality is R. Things get interesting when B1 approaches B2 and theta 1 cap approaches theta 2 cap. That means now they get very close to each other. So the difference between B2 and B1 gets very small, and same is with the longitudes. In that case, A approaches a tiny area which is a delta A cap. If the magnitude of A cap is known and is constant, then it will represent a pixel on the surface of a globe and will have a complete address as delta a cap is equal to r time ab theta cap. That's my representation for this, where b is a distance of delta a cap from north pole along x-axis, and theta cap is its angular displacement from prime meridian along equator. Shape of delta a cap though varies, but its areal magnitude can be kept constant. Thus, it has the characteristic of pixel on flat computer screen. Since theta cap has complete address and it can be accessed from the origin of sphere, therefore tremendous scope exists for picture animation